geometric series. No, they have to have a common ratio. So it's one term being multiplied by a constant number. So it could be 1, then 2, then 4, then 8, then 16, then 32, etc. That's just a series that we don't know anything about. Actually, you have to do that by hand. There's no formulas for that. There's only formulas for geometric and for arithmetic. Now, the formulas for this guy, the summation S of n is, there's basically one formula. It's a sub 1 times 1 minus r raised to the n power all over 1 minus r. If you look back at the paper, there's another formula. They rewrite it as a sub 1 minus a sub 1 times r to the n power all over 1 minus r. But this formula I like better because it factors out the a sub 1 and you only have to use it in one spot. And you get 1 minus r sub n. Either or. But this is going to end up being a calculator problem pretty much anyway. Now, for example, number 1 from the finite geometric series worksheet has 2, 12, 72, and 432. All right. What's n? How many terms are there?
4.
All right. N is 4. What's r? How do I figure out what r is? You take two terms and then you have to divide them. So I'd take 12 divided by 2. So I'd use these two terms, take the newest term divided by the one right behind it. So I get 6 out of that. Do I know a sub 1?
Yeah, it's
2. All right, so now I'm just going to use the formula s sub 4. Because a geometric series goes on forever. So we call it, all right, we're going to find what we call a finite geometric series, which only goes, this one only goes n equals 4 terms. But if we kept on multiplying by 6, it would go on forever and ever and ever. Now this is going to be, what's my a sub 1? All right, 2. 1 minus my r, which is 6. What's n? 4. Divided by 1 minus r, which is 6. Then you put that in a calculator. Go ahead. Do you know 6 to the 4th power? I mean, I'm not trying to be mean or anything. I'm just saying it's a heck of a lot easier to dump it into a calculator. Yeah, so we just go, we set up the equation, or the fraction, 2 times the quantity of 1 minus 6 to the 4th power divided by 1 minus 6. And our answer is 518. And if you would have went through and did 432 plus 72, that's 405. And then plus 12, that's 516. And then plus 2, it's 518. So again, this is just kind of applying the formulas to it. Now I want to show you with these summations, they're a little bit harder. I want you to be able to use a calculator in this case, so I'm going to teach you how to use a calculator. Alright, now we got the Inspire. Let me turn that off. This one, there's something wrong inside of it. There's a short that I can't use it without keeping it logged in. Now, if you had, for example, number 5. Number 5 says the summation of k equals 1 to 7 of 4 to the k minus 1 power. Alright, now, if you hit this key right here, right next to the 9, oh, you got to be in a calculator mode. And if you hit here, next to the 9, do you see a summation anywhere? It's right here. It's second row, 6-1 over, right after the matrices. You plug that in, and then you can put anything you want in there. If you want this to be n equals, well, actually, let's do this. It says k. Let's see if the calculator would do this. K equals 1. Then we go up here to 7. And then we get 4 raised to the k minus 1. You get your answer. So the answer to the question is, can we use a summation well, not the answer to the question, but the idea of, can we do a summation in the calculator? Absolutely we can. We could have taken the summations that we had with the arithmetic stuff, and we could have used this. So the geometric stuff, I want you to be able to use the calculator for those. But a couple things that I want to show you that you can kind of work through here is now, if you look at this term right here, and you think of the formula for a geometric sequence is a sub n is equal to a sub 1 times r to the n minus 1. Do I have something to the some power minus 1 in this problem here? Yeah, that's that 4 to the k minus 1. Well, the general formula for this is a to the nth is going to be this. Now, what would be the first term? What's the number? What number can I multiply by that 4 to the k minus 1 that won't change it?
1.
1. So the first a is 1. The r is 4. And in this case, n equals 7. And you can actually use this formula now. you can use this formula and just take and say it's 1 to the 1 minus 4 to the 7th over 1 minus 4. Same thing here. If I use a sub n is equal to a sub 1 times r to the n minus 1, well, do I have the something minus 1 here? Yeah, I have 2 to the I minus 1. So that's 2 to the n minus 1. Is there a number being multiplied in front of it? No, so that's 1. If you look down at this next one, and we use the a to the n is equal to the a to the first term times r to the n minus 1, I have 2 times negative 2 to the n minus 1. So what's my a sub 1 equal to in this case? Yeah, it's 2. That's your a sub 1. That's your r. Just like here, that's your r, and a sub 1 is equal to 1, because there's no a sub 1 there. Just like up here, your r is 4. So you can not have to use this in a calculator, you could use the other formula. In this case, over here, that's my r, and a sub 1 is equal to 1. This case, that's my r, that's my n is 9, r is equal to negative 2, and a sub 1 is 1. But if I go down here, n is 9, that's a sub 1 is equal to 4, and that guy right there, r is equal to 3. So out of every single one, you can pull out the a sub 1, the n, and the r, and then use the other formula and be done with it. Yes? We know this because of the original formula for any single term. A sub n is a sub 1 times r to the n minus 1. So if I see something with n minus 1, that's going to tell me that's r. That has to be r raised to the n minus 1, because that fits this part of the equation. So this part right here fits this part right here. This part fits this part. So that's how I get my a sub 1 out of it. Then you just kind of go from there. That a sub 1 was 4, because in the generic formula, in the general formula for a single term, is a sub 1 times that r to the n minus 1. So I see a number times something to the n minus 1. So that's my a sub 1. That's got to be my a sub 1. And that, ladies and gentlemen, is the nice thing about the geometric series as opposed to the arithmetic series, because when you get a summation in the arithmetic series, it doesn't tell you exactly what's 1 and what isn't 1 and all of that. It doesn't tell you that stuff specifically. But with the geometric one, it has to fit that pattern. It just can't work outside of that pattern.